Great. So in this video here, we're going to warm up with this idea, and it says multiply the following expressions. And you can see this x is being multiplied by this x. And one of the things we remember, or I hope we remember, is that they're both to the first power. And so if they're both to the first power, we're going to have to add the exponent. So this is going to be an x squared because 1 plus 1 is 2. And so this is how we get x squared. So anytime we're multiplying an x with an x, we get x squared because it goes by this property where if we have an x to some power and we multiply it by another x to some power, we always add the exponents. And that idea comes from, well, if the exponents have the same base. So when I'm talking about base, I'm saying that the x, the big number, the thing that's holding the exponent is your base. If the bases are the same, which they are, they're both x's, that means you can add the exponent. So the base needs to be the same in order to add the exponent. If they are not the same, we don't add the exponents at all. So this is a property that we need to have as a foundation before we can proceed. So like this one here, you can see that both x's or both base are x's. So we can multiply, which means that we can add the exponent. So this is x to the 5th power. So what exactly does exponents represent? Well, it's representing this idea of like counting in a way. So let me retrack this problem. So whenever we have something that is x squared, that means I have x times x, right? And I'm multiplying this with x cubed, so that is 3x's. So the question is here, instead of thinking of this as exponents, we're asking ourselves how many x's are present? Well, there's 1, 2, 3, 4, 5. 5 x's are present, so this is x to the 5th power. Exponents represent how many times you multiply itself, meaning how many times you multiply x. So in other words, we can describe that exponents count or tell you how many times something multiplies itself. There we go. So exponents tell you how many times you multiply itself. Now, there are some rules that we need to talk about when it comes to exponents, and there is about 5 main rules that we need to understand. So first, we already kind of know the product rule. It's the idea if that both x's or both bases are the same, and so both of these are x's, then you can add the exponents. So exactly what we were talking about before. You would add the exponents if the bases are the same. So a quick example of showing that is if I have maybe x to the 7th power and I'm multiplying it, let's give it a negative exponent this time. Well, if I were to add 7 with negative 3, because I can, because both of them are x's, I would really have to work out what is 7 plus negative 3. Sorry, if you hear anything in the background, it's my cat moving around the room. Terribly sorry. But 7 plus negative 3 is positive 4. And so in this case, my answer would be x to the 4th power. So keep everything simple. If things have the same base, you add the exponents. And so this would be my final answer. So in the next one here, we have something called the quotient rule, and essentially it's the opposite of the product rule. You are given 2 x's and you're now dividing. So if multiplication insists that you add the exponents, then division probably is going to insist that you are subtracting off. So in this case, this part's important. If you have an exponent on the top, you're always going to take that first and subtract it with the exponent in the bottom. So you'll notice that the bottom is the one that has the negative sign or the subtraction in front. So whenever you have 2 of the same base, you subtract the top from the bottom. And so if I were to give you a problem like x, maybe this is 7, and then you have x to the 3rd power in the bottom, well then you're simply just figuring out what is 7 minus 3, which is x to the 4th as well. All right, let's get into another concept here. So this is power rule. And the power rule basically says that maybe you have an x inside of a parentheses, and outside of the parenthesis is also taking it to a power. There's also an exponent outside the parentheses. Well, in this case, that means you just distribute the exponent to the exponent inside. So the outer exponent gets multiplied to the exponent that's inside. So this would just simply be x a times b. And so to give you guys an example is, let's say that this inner is x to the 7th power and you have a negative 3 outside sitting out waiting. So that means you're going to need to multiply the negative 3 with the positive 7 that's inside. So this is now x to the negative 21 power. That's possible to have. And we'll talk about negative exponents soon too, and how to deal with those situations. But let's talk about one of my favorites. It is zero exponent. So what do you do when you have a zero exponent? And a lot of people will say, well, the answer must be 0. But that's not quite correct either. In fact, the answer is actually quite simple. It's actually just 1. And let me explain why before we just agree that x to the 0 power is always 1. Let's understand a simple concept like x divided by x, or x is just some number that we make up, right? So let's just do an even simpler idea. What's 3 divided by 3? Well, it's 1, because any number divided by itself is 1, because division expresses how many times that number goes into the number on top. Well, in this case, it's going to be 1. So if we can understand and accept this idea, then what if I were to rewrite this idea using quotient rule? So quotient rule says that if you have two of the same bases, then you would take the exponent on top and bottom and subtract them. Well, what exactly is 1 minus 1? It's 0, right? The exponent is 0. But we want to understand what is the value of x to the 0 power. We want a concrete answer and a real number. Well, we already know that when you divide a number by itself, it's 1. So that means that x equals 0 has to equal 1. And I've just proved it. So these two equations that I started off with were exactly identical. This one I got to an answer because I just used the fundamental idea that anything divided by itself is 1. So when I use the quotient rule to get an exponent of 0, I can explain that x to the 0 power is just 1. So anytime you have something to the 0 power, just remember it's always 1. It's a simple number, just 1. So our last rule is dealing with negative exponents. And this is going to sound really bizarre at first, but when you ever have a negative exponent, we have to change it back to a positive exponent. And the only way to do that is through reciprocal taking a reciprocal. And so you guys might remember that reciprocal means flipped. Like if you have a fraction, you flip the fraction, right? So what will happen is if we can imagine that this x, if we want this x to, look like a fraction, we've always said put it over 1, right? Well, if you put it over 1, this ends up being flipped as 1 over x. And now this exponent that was a negative exponent now gets to be a positive exponent. So now we have 1 over x to the n. And some of you guys are thinking right now, what in the world just happened? Well, let me just break it down. So let's give some space here to see two examples that I want us to look at. So let's say I have 3 to the negative 1 power. I'm going to compare that with 1/3 to the negative 1 power. So one is a whole number to begin with, and the other is a fraction. And we're going to experiment and see what happens. By the way, you can use a calculator, and I think that will really help you to see what happens when you throw a 3 and raise it to the negative 1 power. Same thing with 1/3 to the negative 1 power. See what you get if you put this in a calculator. So I don't need a calculator here because I understand what's going to happen. Anytime you have a negative exponent, what it forces it to do is to take a reciprocal. So if you can think of this 3 as a fraction, or just write it as 3 over 1, you can force it to be a fraction that way if you put it over 1, then my answer will end up turning out as 1/3. And that's just me playing out the idea that I've taken the reciprocal of 3 over 1, which is 1/3. So if I have this to the negative 1 power, well, then this will turn into a 3 over 1 because I've flipped it. I've taken the reciprocal, or I can also write this as just 3 because anything over 1 is itself. And so I want us to understand the basic foundation that negatives, exponents actually flip the base, okay? But I also want us to get more comfortable with, the exponent not just being a 1. So this exponent here can be any number. And you'll notice that what happens is that the base, so notice that this 3 ended up being in the denominator when it was a negative exponent. When you have a fraction, the denominator ends up being in the numerator when it's a negative exponent. So let's play around with an idea that, we're just dealing with x's. Let me get this out of the way. So let's say I have x to the negative second power. What it causes it to do is force this x to now be in the denominator. And so now the exponent can be a positive number. So anytime you see a negative exponent, it means reciprocal. So remember, it's going to flip this x and it's going to cause it to be in the denominator. So anytime I think of negative exponents, I just remind myself, okay, I need to put this in the denominator. And the top just gets to be a 1 because if you don't have anything in the top, it's going to have to be 1. Just like this here, remember this x is over 1 to begin with. So that's where I got the 1 to be on top. But let me change the scenario here. Let's say you started out with a fraction. Let's say this is x and there's a negative 2 in the denominator. What do I do here? Well, because it's in the denominator and has a negative exponent, it's going to switch its place. Now it's not going to be in the denominator, it's going to be in the numerator, and now it's going to be an x squared on top. And the 1 is now in the denominator, right? Reciprocal means flip the fraction. So this would end up just being x squared because that 1 being there is a little bit redundant. So let's try to close up this idea here. So with negative exponents, what it's really causing it to do is change its bases. Like either it changes the base from the numerator to the denominator or from the denominator to the numerator in a way, because it's causing, in the background, it's causing it to flip the fraction. And another thing I want to mention is that we often don't like negative exponents, so we cause it to become positive by switching its place with the numerator or the denominator. So we'll practice this idea some more. So if you don't quite get it yet, don't worry, we're going to do a lot of practice with it. The next thing I want to talk about is simplifying exponent expressions. So there are 2 main things you want to keep in mind with when it comes to simplifying expressions with exponents. 1, all exponents need to be a positive exponent. Kind of like what we were mentioning before with that negative exponent. You want positive exponent most of the time. So in our case for Algebra 2, we're going to say all the time. And you want to make sure that the base are the same before you can combine them. So if you want to combine things that have the same base, they have to be the same base first before you can combine the exponents. So when I'm looking at this problem here, I noticed that x and y don't have the same base. So I couldn't multiply with this x with this y and add the exponents because they are not the same. So the next thing I realized is that what I could do is take care of this negative 2, the negative exponent. So I need to make this exponent into a positive exponent. And to do that, I need to think about switching maybe this x into the denominator. So first off, let's create a fraction here. So when I have this fraction, I've made the fraction because I notice a negative exponent. So this 4 doesn't have a negative exponent. So this 4 gets to stay where it belonged in the first place, which is the numerator. So this 4 is not in the denominator, so it has to be in the numerator. Same thing for this y here. It's to the 5th power and it's a positive exponent. So it gets to stay in the numerator as y to the 5th power. It's just this x to the negative power that causes it to be in the denominator. So I have to put this x in the denominator so that I can write the exponent, this negative 2, as a positive 2. So because I noticed that this had a negative exponent, I have to reconsider its location and put it in the denominator. And so now everything is a positive exponent. I can't combine y and x because they're not the like terms. So this is my final answer. Okay, so I hope this gives you a better idea of how the rules work. We're going to practice a bunch of these in the next video.